So guys, it's morning here. Yeah, so we're gonna do some more problems. I got work in a little bit, so we're gonna get the ball rolling. Maybe hoping we can fit in maybe 2 problems, maybe look at a third or something. But yeah. Again, we're gonna look at a couple problems, so probably look back at maybe 1 or 2 problems, and then that I've already done. See if we can implement it again, and then we'll probably look at a brand new problem that I haven't really seen. So that's the plan. Anyway, we're gonna do our planet of the day. Take a look here. I think we're on Vesta. I think. Yeah. Let's take a look at that. Vesta. Oh, maybe it's an asteroid. Another asteroid. Are we ever gonna get to some planets, man? Jeez. It's one of the largest objects in the asteroid belt with a mean diameter of 525 kilometers. A German astronomer, Heinrich Wilhelm Matthias Olbers. What a name, jeez. Named after Vesta, the virgin goddess of home and hearth from Roman mythology. Nice. Well, that's cool. Another asteroid. I think at this point, I think we're probably all going to get a bunch of asteroids, but oh, we got some comparison. We looked at Pallas and we looked at Ceres. The Ceres is definitely a lot bigger than that one, but okay, cool. Yeah, we're gonna get straight into it. Got about an hour and a half, hopefully. Take a look. So we've done all these problems before. I know this is a backtracking one. We're gonna save that one for later, just because I want to do a little bit of like a backtracking section over here. Even though this is kind of a stack as well, but they're all kind of similar to think about, I guess. Let's do this one. So we'll go to, let's check out daily temperatures. Jeez, it smells bad in here in my house for some reason. Need to clean it. Daily temp. Okay. You're in a regular energy temp. Now think about how we have to use a stack to do this. That's kind of what I was thinking. How is it 4? Oh, these are the amount of days. Oh, okay. 73, 74, 75. So then we go 1 days, 2 days, 3 days, 4th day is 76. Well, why do we have 2, 1, 1, 0, 0? Right answer slash answer. I is a number of days. But why? I just don't understand why this is here. I get it. 1, 1. Sorry, we started 73. We go 1, 1, and then 1, 2, 3, 4. Then why is it 2, 1, 1, 0, 0? What the? I don't understand that. I think here we're gonna create a stack. We're gonna loop fly in temperatures. Oh. I think we're gonna keep a count variable for the number of days. Length temperatures. Okay. Our stack. We're gonna append each value to the stack. I think what I'm gonna do is I'm gonna guess we can get a paint open here. So what I'm gonna do is I'm gonna use a for loop. Oh my god, that's the worst. I'm gonna use a for loop. Add stack. Add to stack. Right? I'm gonna add out all our values to the stack. Wait, no, but a stack is first in, first out. See, before what I was thinking is I could add all the values to the stack and then just pop and just have a count and remember the highest temperature and just keep popping. I guess I could do that and then just reverse the array. I think. So yeah, I'm gonna add all the values to the stack, right? 1, and then I'm gonna pop each value. Each value. Remember greater value. And then just store the count in the variable as I store count in array. My solution probably definitely isn't the best. The space complexity is probably very high. I'm sure you can do it way easier, but this is the first thing that comes to my mind. Oh, and then we might have to reverse the array because I think it'll get stored in backwards. No? I don't know. I think when we go through each value, we're going to store in each value. Right, and 73 would be the first to go. Then we're going to get a different... Yeah, I don't think that'll work. Because we're going to loop through, storing each of these values, and it's first in, first out. So then... Right, stack is first in, first out. Yeah, first in, first out, isn't... Right? Oh no, first in, last out, yeah, okay. Stupid of me. Yeah, that's what I meant, first in, last out. So I don't think that'll work. Yeah. Either we'll have to add in every value and reverse the stack. Oh, we can loot from the back. Stack.append. Temperatures. Oh, stack.append I. Whoops. That's what I meant. Let's just print out. Let's print out stack. Just make sure it did it. Okay, nice. Ow. Okay, let's just test stack.pop. Let's print out stack again after. Pop 73, is that the first one we want to pop? Yeah. Okay. So that worked. So now we have our count variable. Now we loop through wow. Not empty. We can stack.pop. Right, we have count is equal to 0. We pop them out of the stack. Pop count plus or equal to 1. Num is cur num high num. Make this better than like num days or something. Cur temp. Okay, if cur temp we gotta store our highest temp. Oh jeez. Temp. Our temp is greater than temp. Wait, no, we don't want to update the max. Okay, wait. If the temperature is greater, then we found the day. We want to increase this. We want to increase our high temp. Because no matter what, we get one day. It's always one. No, we don't want to fill our stack with zeros, dude. What? While stack is on empty, then we check if our current temp is greater than our high temp. Jesus. Reverse temperatures stacked over everday. Current temp is greater than high temp. Current temp is greater than high temp, then we make current temp equal to high temp. And then we return res array dot append current temp. Res array dot append current temp, and then we make non-days equals 0. Return our res array. Some of this stuff takes so long for me to like put together. Like, I think it's wild stack actually. Oh, jeez. Set temp is equal to stacked alpha. Yes, increasing over days. Let's see how I'm going. Let's see if this is actually a valid solution. 7 739 daily temperatures. For some reason you have to keep track. Find range. Length. Temperatures. -1, -1, -1. Okay, so instead of us manually just adding everything to the stack while stacking temperatures, so we're using the stack. Okay, while stack. So while stack is not empty. Temperatures I is greater than or equal to temperatures stack -1. We stacked up hot. Stack is empty. Equals stack -1 minus I. And we append it to the stack. Okay. So append I. And array. I knew the way I was doing it was incredibly inefficient, but I don't know, I thought I could put something together. We're appending it to the stack. Fine, range length, temperatures. Per temp is equal to stack.pop. So we reset day counter is 0. For J in range I plus 1, length temperatures, check for future temperatures. If temperatures are greater than good temp. So this is obviously the fine we append to the stack. So we're appending every like this. I'm gonna do my solution just to go through with my solution what I was thinking, and then we'll go to the optimized solution again and kind of figure out what the optimized solution is. So obviously my solution is so bad, like it's an all event squared solution with space-time complexity of like, I think it's O of n or O, I think O of n. Yeah, O of n space complexity for this stack and the result, right? Yeah. And then an n squared approach, which is really slow. Fly in range length temperatures. So we're looping through the temperatures. We want to pop from the stack. Oh, we want to make our per temp is equal to stack dot pop, and we want to reset our count to 0. Sorry, num days equal to 0. So where I went wrong here is I used a while loop, but instead I should have looped through the range starting at I plus 1 and gone to the length of the temperatures. We increase our day, on days plus or equal 1. Now, if the temperatures J that we're looping through is greater than our current temp, then we want to reset the counter back to 0. Oh no, it'll come out of the loop and reset it straight away. Actually, I didn't forget about that. It'll reset it here. We want to append to our stack res array I. We want to append res array I is equal to num days. Yeah, and we want to break out of this loop. And we just want to return our res array. So this was the solution we were looking for. I don't even know if it's going to accept my solution, to be honest. What did I do here? We don't even... My gums hurt today, man. So I wonder if it'll accept it. I think maybe it might. I don't know. Time limit exceeded. So this is an n squared approach with an O of n space complexity. So obviously this is a terrible approach. So now we want to go back and do the better approach. Range length I range. So here they use a while loop while stack. So while stack is empty and the temperature's I, so the current temperature is greater than or equal to the temperatures of the top of the stack. And we were popping from the stack. If stack is empty, we want to calculate the value and then push to the stack append I and return our res array. That's our optimized solution, which I think is still an old. I think we still have an O of n space complexity and an O of n squared approach, I think. O of n, okay. What is time complexity? I think the time complexity is still. Is it O of n or is it? Yeah, O of n. Just get rid of this stuff. Time limit exceeded. What did I do, dude? current index minus index of each day. What is that?
Hey everyone, so sometimes I got asked about how I use Leetcode, so let me share a story from when.
So this guy doesn't go in reverse. I don't get why I'm going in reverse here. I don't understand. I don't get it, to be honest. I think this is a much better like understanding of it. Like, why are we going backwards? Like, while stack and temperatures I is greater than or equal to temperatures of stack. See, I like the normal approach. This is kind of a normal approach. Our index is equal to stack dot pop. So we're looping through the stack. If our temperature's I is greater than top of our stack, and do res array index is equal to I minus index. And we just append to our stack. Okay, so here, so while our stack is not empty, our stack is empty right now, so we append our first, which is 73. So while our stack is not empty, which is true, and our temperature's I is greater than our temperature stack minus 1, and we pop, but we don't. So we pop our next variable, so then we append 74. So when we look at 74 and we're like, our stack is not empty and temperature I 74 is greater than our temperature stack minus 1, which is true, then we pop our index from the stack, and our index, our is equal to I minus index should be 1. Didn't accept my solution, my first one. 4 is equal to 5. Bro, this is so confusing, dude. Oh my gosh. Ugh. Dude, it gives me a headache. Like, what? Push 2. Day 3. I is equal to 3. Temperature is 3 is equal to 71. 71 is less than 75, so we push 3. Okay. One, two, three, 4. So we push 69. Bro, where's the video, bro?
Hey everyone, today we are going to solve the Leetcode question, daily temperatures. Okay, so let me explain with this example. We need to calculate how many days we have until the next warmer days. So when we get the warmer days, it's time to calculate the number of days. It's simple, right? And what if we get the cold days? So in that case, I'll keep the days with some data structure. So in my opinion, stack or dayq is good for this question, and I use stack. So that's why initialize stack, and we have to return days, right? So that's why create a result variable and initialized with all 0. So this 0 is very important. So you'll see why later. So 0, 0, 0. How many days? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Like this. And then basically we iterate through all days one by one. So first of all, index 0. And we find 73. And every time we check stack, and stack has data, so stack doesn't have data, right? So that's why we just put index number, so that means days, to stack, so 0, right? And then move next, we find 74. And now stack has data, right? So that's why it's time to compare current temperature and previous temperature. And now 74, right? And stack has 0, so 73. So 74 is greater than 73, right? In that case, we pop the latest days in stack, so that means 0 days, index 0, and then update index 0 with current index number minus 0, right? So that means 1 minus 0 is 1, right? So that's why between these 2 days, so we have only 1 day to get warmer temperature, right? So it looks good. So that's why update 1 at index 0. And then we add current day to stack, so that means index number 1. And then next, again, we find a 75. So stack now has data, so that's why, so it's time to compare temperature. So now 75, and latest day in stack is day 1, so 74. So current temperature is warmer day, right? So that's why pop latest day in stack, so index 1, and update index 1 in result variable with current temperature, current day minus 1, so 2 minus 1, so that is 1, right? So it looks good. And move next. I is now index 3. Sorry, before that we have to put index 2 to stack. And then move next. And now index 3 we find 71. And stack has data. And so that's why it's time to compare temperatures. So 71 versus, so index 2, so 75, right? So in that case, current temperature is lower than 75. In that case, so this day is not warmer days, right? Next warmer days. So now compare 75 and 71. So from 75, 71 is not warmer day. So in that case, we don't do anything. So just add current index to stack. So that means 3. And then move next. We find 69, and stack has data, and that's why it's time to compare temperatures. And 69 versus latest day in stack is day 3, so 71, right? 69 versus 71, so 69 is lower than 75. So that's why we don't do anything. So from 71, 69 is a not warmer day, right? So that's why add 4 to stack. And then move next. We find 72, and now index 5, right? So stack has data, so it's time to compare temperatures. 72 versus latest day is day 4, so 69. So 70 is greater than 69, so that's why we find warmer days. So it's time to calculate days. So pop index 4 from stack, and 0, 1, 2, 3, 4 here. So it's time to update index 4 in result variable. And the formula is just current index minus index 4. So 5 minus 4 is 1, right? So that's why update index 4 with 1. So it's correct, right? So from 69, next warmer day is next day. So that's why 1 looks good. And so we still have days, right? And so that's why we continue comparing with current day, current temperature, and temperature at each day. And now latest day is day 3, right? And the current day is 72. So that's why compare 70, 0, 1, 2, 3, 71 versus 72. So current temperature is greater than day 3, right? So that's why from day 3, we find warmer days, so 72. So that's why pop day 3 from stack, and it's time to update index 3. So 0, 1, 2, 3 here. And formula is current index minus 3, so 5 minus 3, and 2 days, right? So between day 3 and day 5, we have 2 days, right? So looks good. And then we still have day 2. So that's why compare current temperature versus temperature at day 2. So 75. And 72 is lower than 75. So that's why from day 2, still we don't find warmer days, right? So that's why we don't update index 2. So just add index 5 to stack. And then move next, and we find 76. So stack has data, so that's why it's time to compare temperatures. And 76 versus, so latest day is day 5, so 72. So 76 is warmer than 72. So that's why pop 5 from stack, and it's time to calculate days. And 0, 1, 2, 3, 4, 5 here. And the formula is 6 minus 5 and 1 day. Looks good. And we still have day, so day 2. So that's why compare current temperature versus temperature at day 2. So 76 versus 75. So current temperature is greater than 75, right? So that's why from day 2, finally we find warmer days, 76. So that's why update index 2 in the results variable. So formula is 6 minus 2, so 4, right? And it looks good. And then, so we pop day 2 from stack. So that's why now there is no day in stack, right? So that's why add day 6 to stack. And then move next. Now we find the 73. And stack has data, day 6. So it's time to compare 73 versus day 6, so 76. So 73 is lower than 76. So we don't do anything, just add 7 to stack. And then move next, we finish iteration. So we don't update index 6 and 7, but it's okay. There is no warmer days after like a day 6, right? So we have only 73 at day 7. So
See, I didn't catch that part. I thought we were just checking. See, again, like the thing I struggle with the most is really understanding the question. That's what I got to get better at. Like, so here now I understand why there's 4s here, because you don't see from index 75, you don't see a warmer day until 76. You know. And then the reason why it's here too is because you don't see 1 to 72. See, if I understood that, I would have understood the question better. Like, I thought we were just checking, okay, these ones, this is the warmest day, so then it's 4, but there's no more warmer days after that. So it's like, why were we having these values? But that's okay. It is what it is. Okay. Nice. Alright, let's go check out another question. We don't have a lot of time left. Maybe just because I gotta work soon, let's do a different question. Let's do another stack one, because why not? tags. Jeez, why did that take me so long? This is the one we were doing the other day. Decoded string. Alright, on this one? No? Okay, maybe we'll take a look at this one. Even an encoded string returned as a decoded string. Encoding rule is K encoded string, when the encoded string inside the square bracket is being repeated exactly K times. Note that K is guaranteed to be a positive integer. And assume that the input string is always valid. There are no extra white spaces, square brackets are well formed, etc. Furthermore, you may assume that the original data does not contain any digits and that the digits are only for those repeated numbers K. For example, they will not be input like 3A or 2 4. Test a guarantee so that the length of the output will never exceed 10 to the 5. Okay. A2. Oh. Incursion. Damn. Oh man. Got a cramp in the side of my stomach. not too sure. Can I? Damn. Bro, I don't even know where to kind of begin with this. Like, high complexity, organization complexity. If not equal, closing bracket. We append to the stack. Else. Extracting substring to be multiplied. Current string. So while the top of the stack does not equal this, we're building the current string, we're popping it, adding current string. Pops, we remove this. Extract the full number, handle the digits current. Is equal there. Okay, current string. Look at this. While the top of the stack does not equal. Bro, these people out here. Bro. Top of the stack does not equal this. Current string is equal to stack dot pop. I hate underscores, man, I'm telling you. Go string. People doing the lawn outside, dude. So frustrating. I'm better. Okay, so we're popping to remove this. Out of all loop. Oops. Okay, now we need a handle. So now we see this. So then we're I just want to print the current string, see what it looks like. a whole string. Definitely didn't have enough time to do this problem, bro. I could have go in like 10 minutes. Okay. Okay, let's extract current nom is equal to stack minus 1 dot is digit. Then we want current underscore nom. Oh, did I submit it? Oh my god. Okay. Okay, so we're going through. If I is not a closing bracket, we add everything. And then we create a string. If we see a closing bracket, while stack minus 1 does not equal that an opening, curse string is equal to stack dot pop plus curse string. And then the conom while stack minus 1 dot is digit. Conom is equal to stack dot pop plus conom. Curse string is equal to in conom times curse string. Stacked out of n curse string. Ugh. Bro, this stuff outside's annoying me, man. Oh my gosh. Okay, I'm gonna call it here. Just because this is right outside my door now, and this is annoying me. I'm gonna take a look at this later and fully understand it, but I think I have a good idea. I'm gonna take a look at it at work and do it kind of on a piece of paper, so hopefully that'll help. But I appreciate you guys watching, and sorry for all that noise outside. I'll see you guys tomorrow.